So now that we've done this, if you go back to the last step, it says to answer the question how much larger or smaller is 315 than a quadrantal angle. And we figured out how much larger it was than the quadrantal angle 270 degrees. But you could just as well figure out how much smaller it is than the other quadrantal angle in quadrant 4, 360 degrees. So the conclusion that you would come to is very similar. 315 degrees is 45 degrees smaller than the other quadrantal angle in quadrant 4, which is 360 degrees. And so the important characteristic that you would have to include in your drawing if you made this second observation is that, well, this is 360 degrees, so the angle between 360 degrees and the angle you were asked to draw, 315, has to be about 45 degrees, which is half of 90 degrees. So if you came to the conclusion that 315 degrees was 30 degrees less than 360, then your angle would look something more like this. Again, because this looks more like 30 degrees smaller than 360 degrees. Now let's do part B, negative 135 degrees, and here we'll see exactly what I mean by reflect when I put that into the instructions. So we'll start out by working with the positive version of this. So let's work with 135 degrees. 135 degrees is not bigger than 360, so I don't need to subtract 360 from it. So no need to subtract 360 degrees. We'll note what quadrant it's in. So it's between 90 and 180 degrees. So in quadrant 2. And 135 degrees is 45 degrees more than the quadrantal angle 90 degrees. And so if you're going to draw 135 degrees, we'll make some axes. We'll put our terminal side on the positive x-axis, and we would need to draw an angle in quadrant 2 that's halfway between 90 and 180 because, well, 45 degrees is halfway between 0 and 90, and 135 degrees is 45 degrees more than 90 degrees. Again, what's important here is that this looks like a 45 degree angle. It's 45 degrees bigger than 90 degrees. So the angle 135 would look something like this, 135 degrees. And so negative 135 is going to be very similar. Let's go ahead and not draw an arrow, perhaps a circle. Again, its initial side is going to be on the x-axis. And now instead of going counterclockwise 135 degrees, I'm going to go clockwise the exact same amount, and that would land me here in this quadrant 3. So however far you went clockwise, you'll just go that far counterclockwise. And that's how you can work with negative angles. You simply envision their positive version, and however far you went counterclockwise, you instead go that far, but clockwise. Now let's draw 855 degrees. So 855 is larger than 360, so the first thing we're going to do is we're going to subtract 360 as many times as we need to in order to obtain an angle that's between 0 and 360. So if you take 855 and you subtract 360 degrees, then you get 495 degrees. Now that still is not between 0 and 360 degrees, so we'll take that and subtract 360 again, and we end up with 135 degrees. So what we'll do is we'll visualize 135 degrees, which we've already done, and we're going to mark as well how many times we subtracted 360. So subtracted 360 degrees twice. And finally, we'll go ahead and complete the other two steps, which is finding out which quadrant. We've already done that for 135 degrees. That's in quadrant 2. And it being 135 degrees is 45 degrees more than 90 degrees. Or an equivalent thing that you could say is 135 degrees is 45 degrees less than 180 degrees. That's also true. Once you have this information recorded, then the way that we'll sketch this on a graph is first we'll, of course, set up our axes. And we have our initial side on the x-axis. And now the first thing we're going to do is we're going to do 2 full revolutions because we subtracted 360 degrees twice. So if you think about what this means, subtracting 360 degrees twice, what it means is that 855 degrees is 2 times 360, 2 times 360 degrees, plus 135 degrees. And so to draw this angle, we're going to do 2 full revolutions. That's 2 times 365 degrees. And then we're going to go 135 degrees more after that. So we'll start by indicating that we have to go around 2 full revolutions. And you can do this by just drawing a circle like this, little spiral, if you will. And if I just drew this, this would be the angle of going around 2 full revolutions, which is 720 degrees. But we need to go further. Specifically, we need to go 135 degrees further. And so we're going to now add on to this 135 degrees, which takes us to the middle of quadrant 2. And then we can draw our terminal side here, and this would be a representation of 855 degrees. And these are separated, but they should be connected, so I'll go ahead and make sure it looks right. So this is 855 degrees. So you record how many times you need to subtract 360, then you take the angle that results, that's between 0 and 360, you write down what quadrant it's in, you figure out how many degrees more or less it is than a quadrantal angle that's in the same quadrant. Then to draw it, you do as many revolutions as you wrote down here when you indicated how many times you had to subtract 360 degrees, and then you add on this result. In this case, this 135 degrees. Now let's do a small little bonus example here, so part D. What if we wanted negative 855 degrees? So since this is a negative angle, we would work with 855 degrees. We would realize we had to subtract 360 degrees twice from this to get an angle between 0 and 360. And essentially, underneath this, we'd have to do the work from C. And we'd have to visualize what 855 degrees was. So we do all the work from part C, and we draw 855 degrees, and that would look like this, of course. Then to draw negative 855 degrees, go ahead and put some axes next to this and draw it. To draw 855 degrees, we had to go 2 revolutions counterclockwise. Now, when we draw negative angles, we will go clockwise. So our initial side will look like this. And instead of going counterclockwise, we'll go clockwise 2 full revolutions. And then in the drawing of 855 degrees, we went 135 beyond that. So we'll do a similar arc, but going clockwise, and that will leave us in quadrant 3. And this is what negative 855 degrees would look like. Now again, I'll reiterate, there are many different ways to visualize angles, but the way that I think is easiest, especially for angles that are negative or perhaps quite large, negative 135 or quite large like 855 degrees, is first, if an angle is less than 0, work with the positive version, and then at the end reflect it. That is, everything you did clockwise, or excuse me, everything you did counterclockwise, do it that clockwise. Then subtract 360 degrees as many times as necessary to get an angle between 0 and 360 degrees. Many times this will not be necessary because maybe your angle is already between 0 and 360 degrees. Then ask yourself, what quadrant does your angle live in? And finally, how much larger or smaller is it than a quadrantal angle? From there, you can draw the correct visualization.